Hey guys, it's me Prince, and I think you have already gone through the architecture diagram of escrow, and if you have not, I'll link the video in the description. Feel free to go through the architecture diagram first before getting to code, otherwise you might feel a little bit difficult to code and all. So now we can jump directly into the code part. So the very first thing that we need in code is to, like, what data are we gonna store on chain, right? That by that I mean, what is the PDA, what are the data in the PDA that we need, what would be the structure of PDA, or what our PDA will look like. So if you see, we already have a PDA that we discussed in the architecture diagram itself. It consists maker, mint A, mint B, amount, seed and bump. So I have already discussed the use cases, like why do we need to store all of them. Uh, but yeah, we can discuss it once more while we are writing the code. So let's jump into the code. The very first file that we're going to look into is state.rs, and the state has only a struct which has a struct name escrow, which is basically the struct for our PDA, and it has the same thing that we discussed in our architecture diagram, right? Who is the maker of the escrow? What's the mint A? By that, it means that what is the token that user A wanna put in the escrow, and mint B is the token that user A wants in return for mint A. How much amount user A needs in return for the amount he has put into the escrow. After that, what is the seed for this PDA? And every PDA we derive on Solana has a bump, and we store the bump on chain so that we don't have to calculate it each time, which saves compute unit. And in order to derive space, we are directly using a macro from Anchor called init space. After that, one more thing to discuss before diving into the instruction is that we have a like new file here that is known as, that is called event.rs. So what is this event.rs? If something happens, we call it an event. So on Solana, you can generate multiple event on the basis of transactions. We have three events, like just like we have three instruction, we have three events. Those are make events, take events, and refund events. And as the name sounds, this would be similar to what those names says, right? When any user creates an escrow or call a make instruction, the event we are going to generate or is this one. After that, if any user try to take something from this escrow or calls take instruction, will generate this event. And if the trade is not being done and user A wants to refund his amount, and he calls for refund instruction, the event that would be generated is the refund event. You will ask me, Prince, that you said that we when user A calls make instruction, we put his funds into some vault. Then why are we not creating another PDA for vault, right? Because in our vault instruction we had two different kind of PDAs. One was to store the Solana, store the lampposts, and another one was to store the data of the vaults, right? But why not we are doing something similar over here? The idea is that our escrow, we are designing our escrow to trade or share SPL tokens, and SPL tokens are not stored in vault, let's say they are stored in ATA, right? So we'll create an ATA whose owner would be escrow. So it would be a vault, but we don't need a PDA for that vault. It would be simply an ATA which we would use to store the actual SPL token, and data would be stored here in this PDA, and the owner of that vault would be escrow itself, I mean this PDA itself. So only by using this PDA as a signers or giving signer seeds, we can take funds from the vault, right? This will also answer our last question that we had. This will clear that, right? As we discussed in the take instruction, user B directly gives or directly sends money to user A. Like when user B interacts with the take instruction, what contract does is directly transfer money from user B to user A, not to C, that is our escrow, to A. Like this part is not, because we already have our funds from user A in here, right? So once our contract sees that this transfer has been done, it can directly release the fund to B. There is no need for B to C and then C to A. B can directly transfer to A, which will save compute unit, as well as it will the transaction cost will be lower. Now we can get into the instructions, all the instructions part. So we have three different instructions, right? Make, take, and refund. We are going to discuss each of them one by one. So the very first instruction is make, right? And as I've already told you, Solana contracts or writing Anchor contracts are very simple. First, you just gotta decide what are the accounts you're gonna need for this instruction, and after that, the implementation, right? What is going to happen in that instruction? So in the architecture diagram, we have already decided everything, right? So if you notice in the make instruction, we need to do two things. We need to initiate the escrow, and after that we need to transfer funds, that is mint A token, from user A ATA to the vault, which is nothing but the ATA of escrow. So yeah, let's get into it. The very first account that we need here is the maker, who is making this escrow, and he should be the signer, and it's mutable because he's gonna pay for it. So we're gonna the lamports from his account, it's gonna be decreased, so this account needs to be mutable. After that, we have mint A and mint B. Mint A and mint B are the token, right, which user A, mint A is the token which user A is depositing in the escrow, and mint B is the token which user A wants in return for his tokens. So we are just checking that the token program of the mint, that is user A, is providing, it's similar to token program. We have made our escrow in such a way that it is supporting only one token program for right now, either like token 2022 or normal token program. So if you look into look down there, yeah, it's token interface, right? So we are supporting both of them, but it should be same. After that, we have maker ATA. Maker ATA is basically the account where the actual SPL token of user A is stored. As we know that the SPL tokens are stored into ATAs, right, which is associated token address, and we need to check first of all, this is mutable because the token amount of the token from this ATA is going to be decreased as it is being transferred from maker ATA to the vault. After that, we are checking few things, that the mint of this ATA is same as mint A, the authority of this ATA is the maker, and the token program is same as the token program provided by the user. It should not be differ. After that, we have the PDA that we discussed about, the escrow, right? So this is the first time. If you notice, we are not initiating the maker ATA because user A should already have funds A. By this, what I mean, if you want to trade something, right? If you want to go to a shop and buy something, you should already have money with you. After that, the PDA that we discussed, the escrow PDA, right? If you this is the very first instruction, so we are just initiating over here. As you remember from the vault video, wherever we are calling init instruction, so it's the initiation process, it requires some lamport. There should be someone to pay for this initiation. So since user A, the maker, is calling this instruction, so we are making him to pay. After that, we are giving seeds and bump. So seeds, let's say we are putting like three different account at seed here, right? First one is the simple string escrow. After that, we are putting maker key as a reference and seed to LE bytes. this is like seed to little Indian bytes. Why do we need seed? The question is, what is the use for the seeds? Only escrow would be more than enough, right? While we were creating vault, we already had, like, we only had a seed called vault. There were no such extra seeds like maker or the creator or the seed. Why do we need here? So the answer is, we want a single user to create multiple escrows. We are not limiting a single user to create only one escrow. Let's say you are a user and you want to create escrow of your USDT, you want to create your escrow of your bonk and other SPL tokens, right? But if you try to do that with just a simple seed called escrow, then it will throw an error called, this account has already been initiated or defined, like escrow already exists, you cannot recreate it, because the seed is similar, the seed is same, and you are interacting with the same instruction, same maker, and doing everything same. So this will result in an error. Even if I put only maker and escrow, you would be able to create only one escrow. You cannot create multiple escrows. So what is the idea here? The idea here is to put a random seed which would be passed by like either your client side code or the user itself. So this seed would be a random number which would be converted into little Indian bytes, and that would basically randomize this entire escrow, and a single user would be able to create multiple escrows depending upon the number of seeds. I think you get it. After that we have bump. We are gonna store bump later, and space. If you remember vault, we used like manual calculation method to find out the size, which already included an extra 8 byte discriminator. But here we are using in its space macro, it does not uh, includes this extra 8 byte anchor discriminator, so we'll have to like provide it manually over here. So yeah, this is the uh, escrow PDA. After that, the vault that we were talking about. So this is not a PDA, this is a ATA. If you look into the process we are initiating, it's completely different, right? Like up till here it's same, it's an ATA. We are initiating it, and to initiate an ATA you need pair, right, which is maker. After that, we don't have to provide any seed, any bump, or any space, anything like that. We are just checking, or we are just letting them know that the ATA of this vault, sorry, the mint of this vault, which is an ATA, should be mint A, should be equal to mint A. We are giving the authority to the escrow. Remember, we are giving the authority to the escrow, not to the maker, because when someone will call take instruction, and if we give authority to the maker, then how will our contract be able to transfer or release funds from the vault? So the authority of this vault is the escrow. So later we'll use signer seeds to sign and release funds from this. After that, the token program should be same. Otherwise, if the token program is different, let's say the maker ATA token program is some like native token program, and the escrow token program is token 2022. You won't be able to transfer fund from here to here. It will create error. After that, we need to provide these things, these programs, basically associated token program, because we are at multiple places, we are trying to create ATAs, we are checking stuff. After that, we need token program because we are dealing with token program. After that, system program, because we are it's required for all the contract, all the instructions. After that, I think this is very simple what exactly we are doing in the implementation of this make instruction. First, if you remember, we are just initiating the escrow, and after that we are depositing funds. So in initiating the escrow, this is very simple, self.escrow.setInner. So we take everything from client side and few things from up there, and then we put it in the escrow, like we store it in the escrow. So seed, this is the same seed which is used to randomize every each escrow created by a single user. After that, who is the maker, what's the mint A, what's the mint B, what user B wanna receive amount, the receive amount for user B, and the bump. We are storing the bump so that we don't have to calculate it later. And after that, we deposit the fund, which is very simple, that we are just transferring. So this the we take, like, to do any transfer we need three things, right? You need a CPA program, you need the accounts, and you need the context. So the CPA program is token program. The transfer accounts are, if you notice, we have from maker ATA to vault, and we have mint and the authority. So this is the first transfer, right? We are transferring token from maker ATA to vault. So the authority of this token belongs to maker, that is user A. After that, we make CPA context and we transfer. After that, we have second instruction called take instruction. So this is like exact or somewhat opposite of make instruction. So if you remember, in take instruction there is another user, which is user B, which interacts with the escrow, and he is someone who basically wants token A and he has token B, he wants to give it to the user A. So here we need maker, and it should be mutable. Why do we need maker? You will know eventually, I'll let you know. And the taker is mutable. Why is taken mutable? The taker is mutable because we are transferring funds or the token from his account to user A. After that, we need mint A, we need mint B, those token, because these are the token mint account we are interacting with, and the token program for both mints should be same. After that, we need taker ATA A. Now what is this taker ATA A, and what is this init if needed? In the take instruction, we have to transfer funds that was stored in our vault by user A, which is the token A, right, which has mint A, to the taker. Now there is slight possibilities that taker already has that ATA created. Let's say he is giving us bonk and we are transferring him USDC from our escrow. Let's say he already has USDC in his accounts, so he already have the ATA for USDC. Even if he does not has USDC, but he might had it in the past, so he already has that ATA created. In that case, if I put init, then it will fail the instruction, right? It's directly, even without checking that if it exists or not, it will directly try to create the ATA which already exists, and this will result in a failed transaction. The transaction would entirely fail. And let's say if I don't init it, then what would be the problem? The problem would be that, let's say user B, the taker, he never holded or he never had any USDC, he never had any token that is of mint A. Then in that case, our instruction would try to transfer, try to find out the ATA of user B, which does not exist, which will result in the failed transaction. After that, we need taker ATA B. Now you'll say, Prince, why don't we have init if need over here? Why don't have we init over here? And these things, right? I don't think we need to discuss it. It's same. It's init, same as init. If it required to initiate this ATA, we need pair for that. The mint should be same as mint A. The authority should be taker, because we are transferring funds to the taker. The authority should be taker. We are creating ATA for the taker, not for the maker or not for the escrow. So it should be taker, and token program should be same as the token program. After that, the taker ATA. The question rises, Prince, why don't you need to create this ATA? Why you didn't put init over here? Why just mute? I'm sure that you know why it's mute, because we are going to transfer mint B, I mean token B, from user B to user A, and the amount would be like set by user A. But why not init? Because it's same as the make instruction. when user A was trying to create when user was trying to create the escrow, he already had that token A. Here the user B is trying to call the take instruction. He should already have that token B, because you don't trade when you don't have stuff to trade with. We check few things like if the mint B is same or not, if the authority is same as belongs to the taker or not, if the token program is same or not. After that, we have maker ATA B. Same stuff. We have init if needed over here. We have pair equals to taker. Why pair equals to taker? Why not maker? Because if we put pair equals to maker, then maker has to sign for it. And if you remember, the take instruction is independent of maker. He had already created the escrow and he can sit idle in his house anywhere. His trade would be done without him, without any trust, without any disturbance. So we are using taker, we are taking money from taker to initiate the ATA. Like it's not always that maker would not have the ATA, but in case if it does not have it, then that's why we are calling init if needed. If it's already there, this instruction will try to find the ATA, and if it's not, then it will initiate with the help of funds from taker. After that, the authority is maker, and mint should be same as mint B, and token program should be same. After that, we're driving the PDA called our escrow PDA. Why do we need escrow PDA? Because this in the take instruction we will be signing with the help of escrow. And also one more thing that we discussed was to after the take instruction, there is no need for the escrow, so we'll basically close it. So if you notice, we have close equals to maker. This is the only reason we made maker mutable, because he is gonna receive some funds. The lamports in his accounts is gonna change, that's why it's mutable. Does that make sense? So the close equals to maker, what will this do? In the end of this instruction, this just this one line will automatically close this PDA and transfer the lamports that was here for rent exemption directly to the maker account. We are using same seed over here. If you notice, we already stored escrow seeds in the escrow PDA itself, so we are using directly over here. We are using bump directly over here. We don't need to derive bump. It saves like our compute unit, it saves a few transaction cost and all. After that, the vault. Why do we need vault? Because we are transferring funds from this vault to user B for the take instruction. Why is this mutable? This is mutable because we are going to transfer amounts from this account to the user B. Now we have same three token programs: associated token program, system program. After that, if you remember, the idea of take instruction was very simple. It was just to transfer first. I mean, there were two transfer included. First was to transfer funds from user B to user A. After that, we transferred or we release funds from vault to user B. The trade is done. After that, we close all the ATAs, close all the PDAs, whatever was there. So the same thing is happening over here. First, what are we doing? We are transferring from taker ATA B to maker ATA B. We are transferring from taker to maker. ATA B is supposed to be the ATAs of token B. The mint is token mint B, and authority belongs to taker because he is one, right? While take instruction is being called, the authority of the token is the taker. He has the token, right? After that, same CPI context, same transfer checked, and if you notice, the amount we take is the amount that was set by user A when he was trying to create the escrow is the same amount which we save into escrow PDA, and we are using that over here. After that, the second thing was to withdraw and close the vault. So withdraw is nothing but trying to transfer token from vault to the user B. And which token? That was our token A. So if you notice, it's from vault to taker ATA A. The token, the mint of the token is mint A, and the authority is escrow. Since the authority of this token is a PDA, we need to derive signer seeds for this, and the signer seed is going to sign on the behalf of the contract, and then only this transaction would be completed. So we derive signer seeds. In the CPI context, we have new CPI context, that is new with signer. On the normal transaction, like the simple deposit, right? Here we have only CPI context.new because we don't need any signer seeds over here. But in the take instruction, we need signer seeds. That's why we have new with signer, and at the end we have a new like we have extra parameter called signer seeds that we are providing. That we are providing from here. I forgot. So this was CPI context assigner, and we have extra parameter signer seeds over here. After that, we are transferring the entire funds from user A, the entire funds from vault to user B. So if you notice, this all instruction takes place in a single transaction. If any of this instruction failed, the entire transaction would fail. So there won't be any situation where user B transfer funds to user A and he never receives funds, or vice versa. The entire transaction is atomic. It means that either this transfer, this withdraw, this close ATA, this all three instructions would take place, or all of them will fail and roll back. So after that, we transfer the token from vault to the user B, and after that there is no need for this ATA, right? There is no need for this vault. So we basically close the vault. So this is the instruction to close. We need close account. What is the account that we are closing? Destination means whom we are transferring the lamports to, and authority means who is the authority of this ATA. So it's the escrow, right? And since it's escrow, which is a PDA, this should again be a CPI context with signer, and we need to provide extra parameter called signer seeds, and we close the account over here. So this is what our take instruction was. Basically transfer mint B token from user B ATA to user A ATA. The signer for this instruction would be user B. After that, we transfer mint A token from vault to user B ATA. The signer for this transfer would be signer seeds, and we close the PDA, and we close the ATA, and we send the rent back to user. This was basically our instruction called take. After that, we have our last instruction called refund. So this would be basically exact opposite of our make instruction. In this, we need maker, which is mutable because we are going to transfer funds back to maker, and he is also going to sign for this transaction, so he is a signer. After that, we have mint A. If you notice, we don't have mint B because we are not trading over here. There is no involvement of mint B. We are just closing the escrow. After that, we need maker ATA A. It's mutable over here, but if you want, you can make it init if needed. The question is why? Because let's say after creating the escrow, user A might have deleted its ATA. Then in that case, this refund instruction would fail if it's mute over here. Why? Because it will directly try to find out the maker ATA which does not exist on chain, and it will fail. So either you can make it init if needed with a pair equals to maker, or what you can do is find or try to do the same stuff on client side rather than calling it on chain. You can do the same stuff on client side, right? On the client side, even before you call this instruction, you can try to find out, or we already have an instruction something similar to init if needed in JavaScript or TypeScript that does the same thing. It tries to find out if the ATA exists. If not, and then it's created. So you can do that either client side, or you can make it init if needed. And then same thing, the mint should be mint a, the authority should be maker, and the token program should be token program. After that, escrow. If you remember, in the in both take and close, after the after instruction is completed, there is no need for the escrow PDA. So it's mutable because we are gonna like close it and send back the lampposts to the maker. And we check few stuff over here, if this is same escrow or not, if it has mint a. So has one is the constraint that you can use to check if this escrow has this data or this account similar or not. So we have mint a over here, which we can just check if this escrow has mint a or not, if this escrow has maker or not. And if it's not, then a user might be trying to like interact with another escrow. And we also give all the seeds, that is maker key as reference and the seed, and we give the bump. So if you remember, in all two instruction, I think take and refund, or even in the make, we have seeds and bumps similar. It should be similar because PDAs are program derived address. So they are not like randomly generated address like private key and public keys pair. They are derived address. So if you give similar type of seeds, then you will end up reaching the same PDA every time. It won't be a random. So the idea is to get the same escrow in all three instruction, right? So we need to provide same seeds and same bump every time. After that, we have vault, and we don't need to initiate the vault because we know that in the refund instruction we already have a vault that was created in the make instruction. So we can just check if the mint is same or not, if the authority belongs to escrow or not, and the token program itself. And these three programs that we already discussed, why do we need them. And if you remember, the idea was to transfer funds from vault to maker ATA and then close everything, and then we are done. So since this transfer is transfer from a vault, which is a PDA authorized, I mean, which is owned by a PDA, so we need signer seeds for that PDA, and we derive the signer seeds by providing the same seed that we gave to create that PDA. That is basically the escrow string called escrow. After that, maker ATA, maker the maker account, escrow seeds to bytes and bump. To create signer seeds, we need same thing that we use to create those PDAs. After that, if you notice, we are transferring funds from vault to maker ATA, and the authority for this transfer is escrow because the funds in this instruction is stored in escrow, and it's mint a. The transfer is being done of mint a. Same stuff, CPI context is new with signer. Why? Because this is a PDA signed transfer, right? The authority belongs to escrow, so we need to provide an extra argument or parameter. I forgot what it is called. We need to provide extra signer seeds over here. After that, we do transfer checked, and when we send the entire vault amount back to user A. After that, the transfer is done, right? Now we don't need this vault, we can just close it. And same close account, what are we closing? We are closing the vault. Destination means we are giving rent back to which user? It's maker, right? After that, this the authority belongs to the escrow. After that, we already have derived the signed seats over here. We can pass the same signed seats here and close the account, and then we are done. Now you'll ask me, Prince, you never told me or tell us about the event, right? We had 3 events, but we are not emitting any event over here. So we don't do it in the instruction. You can either do it at the end of the instruction, or you can do it all of them together in the lib.rs. So if you notice 3 instructions over here: make, refund and take. In each of them, what are we exactly doing? In make instruction, we are calling deposit function, we are calling init escrow function, and then we are emitting the event. So in the make instruction, we had 2 functions, right? Init escrow and deposit. That's what we are calling over here. We are calling this function, we are calling another function, and then we emit the event, and this instruction is done. So simple. After that, similarly in the refund, we just call refund and close function, and then we emit the event. In the same take instruction, we call 2 functions that we had in the take. Those were these 2 functions: transfer to maker and withdraw and close vault. We call those 2 functions, transfer to maker, withdraw and close vault, and then we emit take event, and then we are done. Very simple, right? So this is what this was our escrow program. Next, I think this video is getting too long. We can do test in another video.